Let's see. So yes, let me just mention again, as it shows in this slide here, this is our last lecture, SOP. So I welcome you to start your cam if you want to. Yeah, so we can see each other, that's fine. That's only if you want to, but it's okay if you do that. So I remember what you look like in case I run into you again, although I know most everyone. A couple things about the class itself. Everything is due by midnight, May 3rd, which is Sunday. Basically, unless there's any extenuating circumstances or anything like that, just let me know. But I'm going to attempt to have the grades in by Tuesday, May 5th, which is what the college wants as well. So I don't think anyone here, I think everyone that's wanting a letter grade has indicated. And that's another thing too, you need to let me know by the end of the lecture tonight or tomorrow if you want the letter grade versus the pass-fail that the college has adopted for spring 2020 in lieu of the issues with and the criteria, or the crisis, I should say, with the pandemic. Okay, so one quick note, you do have a final that's open. The final is self-graded. Basically, there's not any parts of the final that I need to go back. I will review if there's an issue, but it's mostly multiple choice and fill in the blank. So if you have any issues with the final, just let me know and I'll review the questions. But we've had a couple people finish it already, and we've had a couple of perfect scores too. So it is possible to finish the final. And as I stated before, it's basically the whole class, and I looked at it this morning. It's really not that difficult, especially since you can use all of your notes. So, and I'll ask for questions after our little lecture today. Okay, so let's move ahead. So as the topic stated, we're going to take a look at the compiler and basically what's happening in kind of in the back end of Oracle. So key issues in IT software development include performance, version control, excuse me, whoops. Yeah. Sorry about that. Intellectual property and security. So this section, we're just going to go into, we're going to look at performance improvement, including what's known as initial parameters in the compiler and compiler warnings. And I'll let you know what these parameters, they're essentially system parameters, and you can actually control some things in Oracle as far as performance by modifying the criteria of these parameters. So it then explains how to create basically PL/SQL programs, addressing these parameters so that you're looking at higher performance. And Oracle, actually this version of Oracle compared to previous versions, the compiler is complex enough that generally, even in larger databases, you have really pretty good performance. And with the advent of all the higher end specs and resources, it's really not a big challenge as it was 25, 30 years ago. All right. And finally, you learn how to prevent everyone except themselves, even in basically you learn how to essentially create high level PL/SQL PL SQL and SQL source code. And that's one of the main purposes of programming in PL SQL. It's a high-end, as far as performance language. You probably won't run into any issues as far as extremely slow performance unless you're in some type of Cartesian loop or something like that, which we don't really cover. All right, so basically, and yes, so I forgot to mention, yes, module 15 has 5 sections, so I'm only gonna cover one, and basically, as with any of the other modules, it goes into more details. And if you have any questions, please let me know. All right, so in lesson 1, we're going to look at how to describe this PL SQL code type and this is basically a parameter to improve execution speed. We're going to look at the PL SQL optimized level, and basically it's a level of how your code is handled in the compiler. And then essentially I'm going to show you how to access this user PL SQL object settings to see how, basically to see if you are interested. Most coders at your level really aren't digging deep into the compiler to see what's actually happening. But if you're interested, we're going to just briefly talk about the how the code is actually compiled. So the purpose of this lesson in many programming environments, fast program execution is imperative. Yes, if it runs really slow, then it's probably not as useful. In earlier lessons, I mean, you all learned how coding techniques such as no copy and bulk binding can improve execution speed. Basically, this is true in most program languages, and it's essentially true with PL SQL. And then finally, setting the PL SQL initialization parameters can help to make the PL SQL programs run even faster. And these initialization parameters are those ones that were mentioned before. There's basically 2 primary ones, and we're going to talk about those now. Okay, so what are initialization parameters? Basically, they're used to change the way the database session interacts with the Oracle server, or interacts with the compiler, or interacts with the engine itself. They are just like parameters as you know them, but I mean, they're very complex. And essentially what you can do, you can set certain values, and we'll talk about that. Now, all initialization parameters have a name and a data type and a default value. They can be used to adjust security, improve performance, and do many other things. Primarily, and as you read through the module, you'll see some of the others, but tonight we're just going to talk about performance primarily. So many of these parameters have nothing to do with PL SQL. Most of them are essentially a part of the backend compiler, and we really won't focus on them a lot. But as I stated, we'll start with the two main parameters as far as initialization. So don't confuse these parameters with what we've talked about as far as actual parameters, even though they kind of do the same thing, but yeah, in a very, very complex way. So just, these are initialization parameters that are basically associated with the Oracle compiler and backend. And essentially, we've talked about parameters as far as passing values into subprograms and things like that. So don't confuse the two. Okay, 1 second. I'll let Fernie in. All right. So as I stated, there's 2 main initialization parameters that we're going to discuss. And this is PL SQL code type and PL SQL optimized level. PL SQL code type is a varchar 2 with possible value. Well, actually, it only has 2 possible values that we will be concerned with. The first is interpreted, and the second is native. And native is the default value, and I'll get into more details about that. And then the second initialization parameter is your PL SQL optimized level. And this is a number as far as its data type, and it has 4 values, 0, 1, 2, and 3, with 2 being the default. And we'll go into details about those in a bit. All right, so you can actually change these parameters with basically a PL SQL command line or statement as shown in the block code here. Basically, it's alter session set, the name of the parameter equal to, and then the value. And with these, normally, let's see, essentially with a varchar, you have to surround the value with single quotes. With these initialization parameters, you can just type in the word, and you can test that in your, and we probably will, in our Oracle developer. And then similarly, the PL SQL, well, if you want to change the value, so it's just alter session set, so it's either native or interpreted. Essentially, since native is a reserved word, that's essentially why that's blue. And when you type that in, it'll show that way as well. But it's, as long as you're running this command, you're just altering it, this, initialization parameter, and it'll just tell you the parameter was altered successful or the parameter failed. So that's essentially the command line to alter these parameters. And basically, these are, once again, these are associated with your session. And remember, the session is what's active, what you're working in active. And Oracle Developer and many other database management systems are the same. A session is like essentially that tab. So be very careful how you alter these. It will impact the session. And I would just state as you would perform any other type of change, just be cognizant of what session you're in and what values you have set, etc. Remember, these are parameters, so they are associated with that specific session. Any questions about that?
Is there, my question is there a difference between the two? I mean, obviously, I think it's, obviously from the description here, and I think what I've done kind of with the practice, it appears that the native is always going to be faster. So what's the benefit of using interpreted?
Okay, we're going to go into that brief here very, very soon, Eric. I'll talk about whether there's advantages or benefits, and it really depends. But yes, I am going to talk about that. So thank you for bringing that up. And just as a preview, native is usually what you always use, and there's a specific reason, and I'll go into that. And it is truly why it is the default. Okay, so kind of going off Eric's question, if PL SQL code type or that parameter is set to interpret it, actually that's incorrect. The default is native. Is that how it's listed in your lecture from Canvas? Did I get? Yeah, I thought the default was native. In the lecture, does the lecture say the default is interpreted?
No, the default is native according to the lecture. It's in 0.2 or it might be 0.1. I can't remember, but I think it is set to native.
Yeah, it should be native. That's probably me making a big mistake. So here, let me just change this right quick so I don't confuse you. All right. All right, so the difference between the two, basically, to offer a very brief explanation, interpreted is that simply means that the source code is compiled to. Yes, so the source code is compiled to bytecode format. Actually, bytecode format is the native. And native machine code format.
No, I'm sorry. So interpreted is bytecode.
Interpreted is
Native,
bytecode, and that's the default.
yeah. Native is
Yeah,
machine code.
machine code. So I was right.
Yeah, my bad. My bad.
Questioning myself. I do that a lot, especially now. This whole, my brain doesn't work right because it's this whole stay at home. Anyway, so yes, interpreted is the bytecode. And what that means is basically there's essential bytecode within the compiler that will interpret your PL/SQL. This is just your PL/SQL code. And then generally, and this depends upon your machine code format, but generally this will run faster, interpreted. And I'm not going to get into the details of what that is, what's entailed there, but especially with the new backend engines that are running, I will just tell you that if you have something that's interpreting your PL/SQL code so it can run faster, then it will probably run faster. And then essentially native is associated with the native machine code format, and each machine, each processor has its own type of interpretation or type of compilation that it will go to when you're running a programming language. And these are all very complex as far as how they work. Generally, with Oracle, because the engine has and the bytecode is it's very, very high end. And we're going to test this here in a minute, but generally, as far as performance, you're not going, even with large databases, you're really not going to see a huge difference between the two initialization parameters settings anyway. And basically that third bullet point, if you really want to dig into what's actually happening with these initialization parameters, I don't suggest, unless you're really interested, you begin to dig into what these formats mean. Basically, what we want to convey to you now, one, will provide a faster way to compile. The compilation is much faster. Well, it's faster. 0.1 microsecond is probably not that much different than 0.01. But if you're running PL/SQL code that was taking a few seconds, then you probably would see a difference between the settings of these initialization parameters. All right, so here's a very quick, and it's just a very rudimentary procedure. If you went ahead and ran this procedure in SQL Developer, created it and then ran, all this is doing is just looping through this calculation, multiplying the number by 2 and then dividing it by 2. So it's just going through this arithmetic calculation. So if you ran this, and I think I did, so I'll just show you here. So here's the procedure based on that and I have the PL/SQL code type that session set to native. So if you run this, where did I do it? Oh, actually, I went on to the, hold on. Let's go back to the PowerPoint. So I'm just going to take, I was showing you that, I fooled myself. Wait. This is just a screenshot of the developer. So if you ran this code with native, And this is just a procedure, so you can run this, you can create this procedure and run it, but if you ran this, it will take, you see it takes about 0.09 seconds, right, to run. Of course, I don't know how to, my touch screen, all right. But if you change this, if you change the setting of this parameter to interpret it, which I was going to demonstrate that, but what I'm going to do, I mean, that's essentially the way that you would test this. Essentially, you would build this procedure and then change the setting and then launch it. And this second example, this is the one that I'm going to run. And basically, this is a longer procedure. This one will actually take quite a bit more, because what we have in here, we're going to add a SQL statement in our PL SQL. We're going to add this select. And if you're typing this in, make sure don't the first procedure is looping through 5 million loops. This one is only looping, or 50 million. This one is only looping through 500,000. If you run that other procedure, believe me, I did this. It takes about an hour to run. So let's run this one with the SQL code in it, which is the one that I have in my developer here. All right. So I created this procedure. The SQL proc is just basically an example, and we're adding a SQL statement. And if we run this procedure, I have to log back in. This one takes about 8 seconds. You see that? 8. Oops. Of course, you can't see it because I'm not sharing it. You folks aren't speaking up. All right, hold on. All right. So what I did is I created the procedure that was in that last slide, this SQL proc procedure, and it has a select statement. And basically, I'm looping through it 500,000 times, and I'm just writing the number into this variable. So if you run this procedure, or execute the procedure, and this is under native, it takes about 8.5 seconds, a little bit over 8.5 seconds. So if we change this to our interpreted setting, interpreted, is that right? Looks right to me. All right. So I'm going to change the setting of that parameter. So you just remember, you highlight it, saying, and it tells you that the session was altered. So now our PL SQL code type is now interpreted. So let's see if it changes the time that this procedure will run. So if we launch it again, yeah, it doesn't seem like it's going faster. It actually took longer. So that actually took 8.7 seconds. So generally, any professional will tell you that, yes, the interpreted should run faster. So why does that not run faster? Why, does anyone have an answer why that doesn't run faster without looking at the lecture? Yep. Hold on a second. My son is texting. No answers? Is everyone still there? Did I lose my students?
No, I just don't remember why it wouldn't run faster.
Okay. So let me go back to the lecture. There's a specific reason why it doesn't run faster. Brian said he thought native was faster. Well, it really depends. Usually native is faster. But in that case, it wasn't really, it was only, 2/100ths of a second faster. Generally, you'll see quite a difference between the two. So let me share the lecture. All right. So if you're wondering why it was not faster, it was not faster because the initialization parameter does not have an impact on SQL code. Matter of fact, there's no such thing as far as parameters in the compiler that will change the time that the SQL code in your PL SQL blocks will not change the performance. It will not speed up. SQL to SQL, all of that depends upon other factors. So basically, yes, if you have PL SQL, yes, changing the parameter will, improve the performance. But if you have SQL, then that's where you have to go back and take a look at other. So PL SQL engine executes faster, but SQL statements always execute at the same speed. And SQL statements usually take far longer than PL SQL code. And to speed up, things like in SQL, there's other parameters like indexing, correctly indexing the tables, using a bulk binder, bulk binding, which is basically a setup where you're binding things during a parsing phase. And we're not going to go into that before you run them, so that it assumes things like a single table or specific columns or specific indexes. So that's primarily the reason why that initialization parameter doesn't change when you have SQL. So the last thing, or one of the last things I want to talk about is putting together your code. Question, Peter?
Yeah, I just a quick question. If you ran the code multiple times, let's say made no changes and did the same thing over and over and over again, would the time be the same? Like let's say if this one took 3 seconds, is it going to be the same thing over and over again, or does it vary?
It won't vary. I mean, and even with especially now with the resources even on your laptop, they're pretty stable. Your processor, your memory, et cetera, which has an impact on it. But ultimately, the Oracle developer is set so that it's optimizing all of your PL SQL code anyway, which means that it's always choosing a fastest to completion as far as throughput. So it will generally be the same. You can run it 1,000 times and it'll be, and that's one of the things that most of these DBMS or these languages like PL SQL have done quite well in their compilation. I mean, it'll generally be, you can try that on any of your blocks of code, run it several times. You'll see that your time doesn't change substantially.
Okay.
And Pete says, but maybe affected by other processes that are, yeah, well, obviously, if you have other processes running, other high resource applications running, yes, that will impact it. But even those, I mean, if you have a quad core processor with substantial RAM, I mean, it really won't affect it that much unless you're running high database processes. It's very interesting. Now I can remember where literally we would have to shut down all of the processes to run these high-end queries because they were pretty much, you know, taking up very commanding as far as resources. But now it's not too big of a deal. Yeah, Pete says, good thing is that DBA can manage zombie and long-running high process. Yes, and then you also have a database administrator that's constantly checking for performance and things like this. If you have what we call useless code, remember a DBA will have some type of compilation procedure running to catch things like, well, this code is looping when it's not, doesn't necessarily need to loop and things like that. So let's talk about useless code. You look at this procedure here, if you built something like this, and basically it's just centered around redundancies. It's saying basically, if this is true, then print this. If it's not true, then it'll probably never print this. So this is what we call obviously bad coding or obviously bad procedure. And basically and yes, in the lecture it says silly, and it is truly silly. And you can see that. Why would you want to code something this way, where you're checking a number, where you're setting a number at 1 and there's no changes in the procedure, there's no parameters, and you're checking to see if that number is that number that you set it at. So that's what's known as very, very silly and obviously bad coding. Does everyone see that? Yes, no?
Yes.
Yes, okay, thank you. Okay. So let's look at another example of not so obvious. So if you look at this procedure, is this an example of very bad coding? Basically, we're running a loop. We're actually running a reverse loop, and we're going to do something if it's greater than 25, et cetera, et cetera. So any comments on this particular procedure? Would there be a reason to run something like this? The remainder should never be larger than 25. Are you saying, Brian, are you saying it should never be, or it will never be? Never be. So does everyone see that? Does everyone see that basically will the remainder, will it be, well, this is saying greater than 25. Will this condition ever be true?
No, I don't think so.
Okay, why? Explain. Walk through the code, walk through what this procedure, how it's running. No one wants to volunteer. Who's that spoke up? Was that Fernie? Brian? What do you think? No one wants to talk. I don't want to talk all the time.
Oh, wait. I'm sorry. I couldn't unmute my thing.
Okay.
Can you hear me now?
Yes.
Oh, yeah. I was just saying, I think the only instance is right is if the number is 1, right? It's that if it's 50 divided by 1, that's the only time it's larger than 25. Otherwise, it's always going to be less than 25. Because the next time would be 20. It'd be 50 divided by 2 would be 25, and that's not greater than 25. So it's kind of close to useless.
Yes, so it's very, very close, and it is actually useless. So
Yeah.
Does everyone see that? I mean, it will never be essentially, once, well, that's the only instance is the first instance, which, why would you do that? All right. So basically, that was just an exercise to show you that be very careful in your PL SQL coding practices to make sure that you're not building useless code, especially in procedures. All right, so the next initialization parameter is just the optimization level or the optimized level, PL SQL optimized level. This can be used to control the compiler and basically what it, levels of performance. So, and what the integers mean, well, the parameters of, or the parameters of the parameter, or the settings of the parameter go from 0 to 3, inclusive, meaning that it can be 0, 1, 2, and 3. The higher the value, the more effort. Now, with these new compilers, I mean, there's a ton of operations happening behind the scene to make sure your code will run at its highest performance. So these are this is optimization at its highest level. So the higher the value, the more things that the compiler is going to try to do to up the performance of your PL SQL code. The default for your optimizing compiler is 2, and I will explain why. So basically, when it's 0, the compiled code will run more slowly because, but it will work with older versions of Oracle. This is why most of the Oracle developers or the Oracle professionals will want you to update, because performance is performance. But if you set the optimized level to 0, it will work with any Oracle software back to Oracle 7, which is many, many years ago. So this is similar to creating a document in Microsoft 07 or 97 or 2003 or whatever, but saving it, well, actually that should say, this is kind of outdated, that should say Microsoft 2019, and then saving it as 97 2003 format. So basically, if you've done something like that, you know that the Microsoft Word will indicate that either you're saving it as an earlier version, and the formatting may be different. It will actually update or downgrade the format of the document based on what you're saving it as and what you're opening it as.
So how would you know? So I guess if let's say I create something and I set it at optimized level equals to, say, 1, 1, 2, or 3 or whatever, is Oracle going to tell me saying, okay, there's going to be an error message that says, I'm sorry, your version is too old, so therefore by default I'm going to switch you down to 0?
No, it won't. It will not automatically switch you down. Here, if you have it, let's say, well, it's not a huge problem now, but let's say you're running a piece of code, and for some reason you have an Oracle 10 developer running. Then what you will need to do, you need to make sure that optimized level is on 0. I don't know if that answered you.
So when the comment here says older version, what does Oracle deem as old? I mean, I guess the older version, is it like two what is it?
Generations.
2 versions back, 3 version. What's the guideline?
That's an interesting question. I've worked on so many different versions of Oracle, and I have not had any major issues as far as compilation. But I haven't run complex code either. Oh, something writing in the comments. So to answer that question, I would say Oracle is not like Microsoft. Oracle is truly backwards compatible, but the compilers need to be addressed. So, and I think we're on Oracle. What are we on now? Oracle
12G.
12G, right? Which is quite higher than Oracle 8 or 9 or even 6. And I'm just guessing. I haven't done it specifically, but I'm pretty sure you can run any of that older Oracle compile code on this 12G if your optimized level is 0, because what will happen, it will go back to all those layers of compilation that's needed to understand that code, and then it'll run it. So I don't think there's a limitation. Of course, if you go back to one of the original versions, maybe, but even then, I think the complexity in those compilers, especially the 12G compiler, it will attempt to do everything it can to understand that code. So I will state, in my professional opinion, I don't think there's a limitation as to backwards compatibility.
Got it. Okay. All right. Thank you.
Welcome. All right, continuing to explain the optimization levels. One, the compiler will remove unnecessary code. It'll actually read your code, interpret it, and then remove anything that's unnecessary before it's actually compiled. Useless code, loops that will never run, loops that aren't being checked, or conditions that will never be a part of the scenario as far as a loop or a conditional statement. Yes, there's libraries in the compiler that when you set it at level 1, it will actually do much more than just interpreting your code and preparing it to be executed. And as it states in this slide, definitely it would not compile those 2 procedures. It would give you an indication. You would receive an indication that I think in the new compilers or new optimizations with optimizer, you would get a warning that the procedure consists of useless code. Okay, so continuing, the order of the source code is not typically changed. Where am I? Yeah. But basically, you will receive a warning that there's useless code in your program. If it's set to 2, which is the default, the compiler will remove useless code as before, but it will also move code in different spots. So basically, all that means is that, let's say you have a package subprogram and one is being called more than the other ones. It'll actually, and just think of this physically, it'll move it first in the line of subprogram so it doesn't, your code does not need to go through, or the compiler does not need to read through code that's not being ran. So basically, it will conceptually move the code to a different place so that it will execute faster. I wouldn't think of that as being physically moved, but that will give you a sense of how it can be ran. So for example, frequently, just what I stated. So your source code is never changed, only the compiled code. Now remember, you won't see this movement in the source code. This is only happening in the compiler during compilation. This is all this movement just to make sure that when that code is executed, it's going to run as fast as possible. And then if you set your your optimizer to level 3. It gives all the benefits of 1, 2, plus what's known as sub-program inlining. And this is basically rearranging everything to follow any type of execution scenario. So once again, it's all happening in the compiler. It's all happening so that when you execute your code, then everything is going to run faster. So essentially, if you conceptually think about what's happening in the compiler, and generally, this is a good way to make sure when you're building your code, you know, if you think about the organization of your code, then this is a good way to ensure that, well, I'm pretty certain that this particular procedure or subprogram is going to be used more often. You don't really need to worry about that too much, because these newer compilers are going to take care of that. And then you can actually change that with this optimization level. And once again, the default for your optimizer is 2, but you can change it to 3 and see, maybe see the difference in some of our code. Some of our code is very basic, but if you run across any more complex codes, then you definitely would see a difference as far as performance with this optimizer.
Is it good practice to always put in the optimized level?
Since it defaults to 2, unless you have very, very complex code, I would not necessarily change that. Because that's the best of work, that's the checks and balances. If you wanted to begin to rearrange mostly your code as, you know, in the compilation phase, yes, it would be, well, it really depends on your scenario. Once again, that's a scenario thing. If you have very complex code and you're thinking that performance will suffer, then yes. But you can always check that. But with these newer database systems, all of them, SQL Server, MySQL, Oracle, and all of the languages, Python, etc., they all have a default compilation level that's similar, very similar to what's set in PL SQL. So generally, you don't need to worry about that as a coder. But I mean, if for some reason after you run your code, you feel that there's a need for high performance, yes, you probably want to check that and change it.
Okay.
Yeah. All right, so if we take a look, and basically the initialization parameter, the optimizer, I call it, it's just another, the command is just an alter session, set your PL SQL, then you equal to, you know, that certain number. And basically I'm just showing you if you have a procedure and you'd like to call it and then change the optimization level, then this will be the command structure. Okay, any other questions about the initialization parameters, the PL SQL type or the optimizer? Feels like useless settings. When I set it as highest performance at all times, does it take up resources? Well, that's Peter's question. It does seem a little bit useless. At this level of coding, it is rather useless. You rarely will even need to worry about performance. And I've discovered that even more complex code, performance is really not an issue. What happens, though, I'll tell you this, is that if you're running essentially a language, a different language, or you're running applications and they're bogged down, and this happens all the time during the database retrieval phase or writing phase or whatever, then it's usually because, well, the DBA will say it's not because of the database or the structure, but it's usually because there's some type of, you know, redundant code or useless code, and that's usually when you want to check it. On the PL SQL side, I can tell you this now, all the years that I've been using PL SQL, even in more complex scenarios, I haven't run into any major performance issues as far as applications. So it does seem useless, but it is to be frank, it's mostly useless, but it's a good need to know in case you're worried about performance. I mean, that's my best way to placate or provide an explanation. So the last thing in this whole scenario is you can see how your PL SQL programs are compiled by querying your user PL SQL object settings. And this will basically give you all the information about those particular parameters. As you see, if you ran this select query on a, you know, this specific test proc, which may be a procedure or whatever, you see it, it'll give you the type, the code type, which is that PL SQL code type, is interpreted, and then the optimization levels too. So basically, if you want to see how things are set, you run that query, select name type, and it's in that table. Excuse me, that user PL SQL object settings. That has a lot of information in there. If you're interested about anything that's associated to your blocks of code, you can always retrieve that from that table. Hopefully, you're all using that table to take a look at some of the attributes of your code. And that's essentially the data dictionary view. And here's just another example of querying that table to pull out information about a subprogram. Any questions about the user PL SQL object settings table? You should all take a look at that. Do a select star. There's quite a bit of information in that table about your code, your procedures. All right. So our terminology for this lesson, PL SQL code type, initialization parameter, PL SQL optimized level, PL SQL initialization parameters, that's what those are, and then your user PL SQL object settings table. And then basically you learn about the parameters, the initialization parameters, PL SQL code type, PL SQL optimized level, and then you learn how to query that table to see just how your PL SQL program was compiled. All right. And finally, I do want to thank you all again for your endurance through this semester and just dealing with all the things that has happened. I do want to open it up for any basic questions about the final. So if you have any broad questions or concerns about the final, now is the time to ask them. And I'll say again, it was open on Sunday, last Sunday, and it will close on midnight on the 3rd, next Sunday. And it is self-graded, meaning that I don't need to go in and review any of the questions unless you all have concerns or issues. So any other questions, concerns?
I haven't even opened it yet.
Okay. So when you get a chance to open it, yeah, take a look at it. I don't think it's going to be that difficult for you, and that's just not me speaking of the one that created it. I don't think it's that it covers the whole course, but it's almost like a cert exam. I don't know if that makes you feel more comfortable or less.
I don't have a question about the final, but I do have a question on the on one of the homework. So
Go ahead.
I guess I can talk to you afterwards.
Oh, you can talk about it now, Eric. Go ahead.
Well, the I think there was one or two emails that I exchanged with you, basically stating that for section 15.3,
Yes.
I have the coding, everything's identical, but it's not generating the output. It's not generating any output.
Yeah, I took a look at your email and I ran it a couple times, a couple different ways. I'm not sure what. So what is it? Just what did your error state?
So the what it came with is, number one, when I ran the code just by itself, I don't I'm trying to remember what I said. It did not give me like PL SQL, executed correctly. It did not give me that.
Right? What did it give you?
Hold on, I've got to pull it up.
Okay, so let's see, what did I send you?
Okay, sorry about the delay. The message I got says it says version_proc omitted optional auth ID clause, default value definer used.
Oh, geez.
So I think because of that, I think it's preventing me from actually getting. To me, this is, obviously it says the procedure was compiled, but also following along with this error message. And I think that's preventing me from getting that output that I'm looking for.
And this is just the version, checking the version of your
That is correct.
SQL developer, right?
Yeah. So I wasn't sure if this was it didn't seem like it was pulling from anything else. It didn't seem like that, at least when I looked through the code.
Yeah, basically all that is just pulling from your system.
Correct. So it doesn't look, I don't know. I mean, without an output, it seems like it's not pulling from my system. So that's why my comment to you, I think in my last email, was whether or not this was perhaps maybe a setting, like maybe a setting in SQL Developer, or is this something with my system, or
But when
I couldn't figure it out.
Did you actually run the procedure to see if it gives you your release version?
I did. I ran it multiple times, and it's the same output.
I mean,
which is nothing.
It didn't. So it does. So does the procedure actually get created, or because it was a procedure?
Well, it says procedure was compiled.
Well, that's created, compiled. So have you
Correct.
tried running the procedure?
I did. Yes.
All right. Let me rejoin a meeting with my local developer. All right, let's see. So, and your code is just like this, correct?
Exactly. Yes.
And there's nothing else.
Yeah. See, I cannot even get to the point where it says the procedure successfully completed. I cannot even get to that part.
Yeah, I was looking at your screenshot, and this has to be a system issue. If your procedure, if it's given that error message is, yeah, it could be several things. And it could be something, but we're all using the same version.
Correct.
Using the same instance. Well, not the same instance, but the same, basically, or the RCL should be the same. And you tried, essentially clearing, rebooting, restarting, clearing, all that.
Yes, I've done this. I'm sorry. Yes, I've done this. I've tried again. I thought maybe it's because, sometimes I think for me it's occasionally, rarely, this SQL Server gets a little glitchy. So I did try to restart it, ran the code again, and it's still giving me the same output.
Yeah, see, that's something that, yeah, you're looking at a system, mostly it could be a version, well, I'm not even going to go there, but it is primarily pointing to some type of system issue. I'm trying to think.
Okay.
Yeah, I don't want you to go into the compiler.
I mean, I'm not gonna push this any further. I mean, if you think it's a system issue, but I was just wondering. That's the reason why I wanted to ask you to see
Yeah.
if maybe it's something I did or.
No, it's not
Or-
anything you
or-
did. That error message is pointing to something, a problem with your instance for some reason.
Okay.
If you want to investigate it a little further, you can always log in as another user, create another instance. But that's strictly up to you. But yeah, I wouldn't worry about it. I'm definitely not going to count off for that particular error message if it's not,
Okay.
procedure's not being created. Have you tried changing any of the code in the procedure?
Changing in what way?
No. Like modifying, let's see. Let's see, DBMS DB version. Wait a minute, what do you have? Hold on. Let me look at your error message again. DBMS DB version. It's giving you an authorization ID. Okay, now that, yeah. In this particular procedure, no, that's, you shouldn't, that's not going to make any difference. I can research that a little bit, Eric, and maybe I'll respond to your email. But don't worry about it. I'm not going to deduct any points for that. Yeah.
Okay.
That's a very, very, very odd and unique. Yeah. For this particular procedure, which is very, very basic, to get that error, that type of error. Brian says he cut and pasted from the solution and didn't get an output either.
Correct.
So, well, I didn't cut and paste from the solution, but let's do that. Let me rejoin the meeting. Since we have time. All right, 15.3. Let's take a look. Anyone else tried this? Tried 15.3 and had?
I wasn't able to do it either. I kind of gave up on it and moved on to 15.4.
Okay. Well, I did not have any issues with it. I don't know. I think you're all right. It's just a version checker. It shouldn't be. All right. I'm going to bring up the. Give me a second to get this in. Okay. Well, that's it. Okay, so here's the procedure, right? This version procedure, and basically you're checking using this. It's just basically so I'm going to run this again. All right. And it compiles fine for me, right? And then just brings up that table. And that's all that ensures that you will get text. So if you run that procedure, hopefully this is what you're all. I'm going to put in an anonymous block. All right. Don't forget your semicolon. So if you run that, Yeah, that's right. If you run that, you should get release. See the output there? Does everyone see that? So I'm not sure why you all are receiving. So make sure you run the procedure and then set up your little. Actually, you don't really have to run that. And then run your procedure and it should give you the release version. Excuse me. I'm in the dark here. Now, does that run?
Okay.
Now I'm getting
Oh,
the
actually, I just,
Okay, Brian, you said you're getting the correct output?
Yeah, I did. It says release 12 is installed.
Yes, that should be the correct, that comes right from the procedure. Release, and then this DB version coming from that is installed. But Eric is getting a compile error on the procedure. And Eric, did you try running the procedure itself?
I tried, but actually, I tried, but what I was, the information I was getting was from the error message, the document I sent you. So I'm gonna have to start up a SQL developer and try it out myself.
Okay.
Maybe, yeah. We'll try it again.
Okay, great.
All right, thank you.
Yeah, Brian's getting the same thing, but when you run the procedure, Brian, did you get the output, release 12 is installed? Yes. So I don't think that prevents, I think it compiles successfully, but there's an, some type of authentication clause that's happening in that version, in the procedure itself. All right. Any other questions? Comments? Okay, remember you have 5 sections in 15, or 5 lessons. So everything is due by Sunday, along with the final. If you have any general questions about the final, you can ask. If you have any questions about the assignments, which they're really not that bad, you should be able to knock them out pretty quickly. Feel free to message me. And once again, those of you that want a letter grade, vice pass fail, please let me know. I will be submitting grades more than likely on Monday or Tuesday. Okay. Well, that's, once again, I want to thank you all for grinding through the semester with me. It's been a very interesting adventure, including the last part of our semester. I do appreciate all of your hard work, and well, just finish off strong and you will do fine. And maybe I'll see you all in a different class. All right.
Okay, thank you.
Welcome. Thank you, Eric.
Thanks so much, man. Appreciate it.
Yeah, Fernie.
Thank you.
Take care.
Bye.